Alrighty, cool. Let's learn this next example through another question. Like I said, for a lot of the math-based questions, I don't like you guys doing that as pre-learning because I find it's really hard trying to teach yourself math, so that's why I'm doing them. This is basically exactly the same as we saw last week. The only difference is we're working in reverse. So the first example, we were going from mass to energy. Okay, now we're going from energy to mass. The last one we saw as well only went up to the merit level, and this one does go up to the excellence level because there's more steps involved in it. You can see this one here is a very common question that they're asking. So they say solid lithium bromide is easily, readily dissolvable in water. It's giving you the equation, and it's giving you the enthalpy, and they want you to classify this as an exothermic or endothermic reaction with reason. So when I'm looking at that real quickly, I can see that it's a negative number, and so negative tells me exothermic. And that's all you got to write for that one. I think this is usually an achieved or maybe a merit at most. All right, cool. Next one. So I'm just going to skip that one. I figure you guys can write that down yourself. This one here is the one we want to unpack. So we're looking at the equation for dissolving potassium bromide in water. And they've given me the equation and they've given me the enthalpy. So they've given me two different dissolving equations, which probably tells me that you're going to have to use both of them in some sort of context. So that's going to have quite a bit of math. In fact, I probably will grab another piece of paper, because we're probably going to need more things to do the math working. I'm very mindful we never have enough space for that, especially with the format I like to use. All right, so let's start to color code things so that way we don't accidentally confuse our numbers together. And let's write down all of our knowns and our unknowns. So our knowns in this case, and I'm trying to color code it so that way we can keep track of which one is which. The first one is our delta H for lithium. So this is the lithium bromide. We know that the delta H for that is negative 48.8 kilojoules per mole. So I'm pulling that number from up here because I'm not sure exactly what I'm going to have to use yet. This one here is the delta H for the potassium bromide. So KBr delta H is positive 19.9 kilojoules per mole. So what's useful for that we should already kind of observe is that this one is exothermic, this one is endothermic. So they're both dissolving reactions, but they're both causing different temperature change. Cool. So both the lithium bromide and the potassium bromide are dissolved in 200 milligrams of water in separate beakers. So that's something for us to kind of keep in mind is that 200 milliliters. I don't think that actually comes into play in this question, but it's something for level 3. We'll just note that down. So volume is 200 milliliters in case we need it for something. They also say that you are using 20 grams of lithium bromide. So for the mass of my lithium bromide, M is equal to 20 grams, resulting in the energy change. They want you to calculate the mass of the potassium bromide. So finally, they've told me my unknown. And they told me my unknown is the mass of lithium bromide. So that's my unknown. So we're trying to find the mass. So they want you to calculate the mass of lithium bromide. You will need you'll need to dissolve in the second beaker in order to have the same energy change equal to the magnitude of size. So what this is basically asking you is, based off of this first reaction here, how much energy is released in that, and then flip that and go, okay, then how much energy do I, how much of the potassium bromide do I need in order to make that same amount of energy? Are we okay with that? So it's a two-step problem. Step 1, how much energy is released from the lithium bromide, and once I have that answer, I can then use that to figure out how much potassium bromide do I need to have the same equivalent energy change. So step 1, we need to know the energy release for 20 grams of lithium bromide. And then once I have step number 1, I can use that for step number 2. What equivalent mass of potassium bromide is needed for the same energy change? I'm sure I spell equivalent right. I know I didn't. Equivalent. Y'all know I can spell. Oh, I spelled that real wrong. There's a lot of things I'm good at, but spelling is not one of them. There you go. Equivalent. Are we okay with that? Okay. So first thing I need to keep in mind then is when I'm looking at this reaction, I need to do some conversions because basically what we have here is the dissolving of lithium bromide. We have this in kilojoules per mole, but the problem is lithium bromide is given to me in grams. So it's the first problem I have. So I need to convert the grams into moles, and then once I know that, then I'll be able to use this equation here. I'm just going to grab a new piece of paper. So first thing we're going to do is we want to convert the lithium bromide, the grams, into moles, so that way we can plug it into this equation here. So remember back when we did titration, N equals little m over big M. And they've given me the mass of lithium bromide over here. It's 86.8. So N equals 20 grams divided by the 86.8 grams per mole. Again, I like to write down my units to double check myself. Grams and grams cancel out, and I have per mole. That's good news because that's what I want as my final answer is in moles. So I do 20 divided by 86.8, and I get my N value is 0.2304 ... moles. I don't like to round until the very end. That's just a habit that I have. Are we okay with that so far? Yes or no? Sort of. Do you want me to backtrack anywhere? Okay. So first thing I need to be mindful of is that when I'm looking at these equations here, that is in kilograms per mole, or sorry, kilojoules per mole. So I can't do any mathematical calculations to figure out the amount of energy if the other unit that I'm using is not in moles. So that means in order for me to get there, I need to convert grams into moles. It's just like in titration. You guys did the exact same thing. Now, in order for me to do that, I need the mass divided by the molecular mass. So the mass that I have is 20. I found that from this question here. 20 grams of lithium bromide is dissolved. I also was given the molecular mass of lithium bromide, and that's 86.8, and they figured that out based off the mass of lithium plus the mass of bromine. So they've done that math for me, so I don't have to do that math. So that's why I've taken the 20 grams and divided it by 86.8. The grams and the grams cancel out. This is why I like to write my units down, just to kind of be a nice little idiot check. And then I see that I have per mole, but that's underneath the division sign. So it's per mole, which changes it back to mole, which is what I want because that's now talking about amount, which then I can use for this guy. Cool. All right. My next step then is I'm trying to figure out kilojoules because I want to figure out how much energy is released from that reaction. So when I think about this logically, if I do my delta H times my N, my moles and my moles will cancel out, and I'll be left with kilojoules, which is what I want. I want to figure out how much energy change is there in that reaction. So if I want to figure out energy change, I do that by taking the delta H and I multiply it by N. So I would get 48.8 kilojoules per mole, and I would multiply that by that 0.2304 like long number. Okay. Again, idiot check myself. I see that's per mole and that's mole, so the moles cancel out, and I'm left with kilojoules, which is what I want. I want to know how much energy is released from that reaction because I need to know what is the equivalent then that I need in order for the potassium bromide to dissolve. Let's do that. So 48.8 times my answer from before. So I love to leave things in my calculator because when I do that, I can just tell it, use the answer from before. So I don't have to keep writing the whole number down. So what that tells me is that I'm going to release 11.2442963 kilojoules of energy. So that's the energy I'm releasing. That's what I'm getting there. Give you guys a second to get that down. I'll do the next step. Actually, I still want the green. I can zoom up. Oh, a little yellow. All right, questions, concerns, or comments? So I need the answer to one question to be able to answer the second question. So it's a two-step problem, which is why it goes up to excellence. All right, so something to keep in mind is first question here was the energy release of 20 grams of lithium bromide. So that was the first step. Second step here is what is the equivalent mass of potassium bromide needed for the same energy change? So basically, this answer here, I am now using for the second part of the question, because the second part of the question is, if I have this much energy and I know what the delta H is for my potassium bromide, how much do I need in order for that reaction to occur? So we're still using this equation again. We have energy change is equal to the delta H times N. And N is now my unknown because that is asking for the amount of my potassium bromide that I need. Are we okay so far? Right, so if I want to get N by itself, I need to divide both sides by H. So that way the H cancels out here. And so I get N equals the energy change divided by the enthalpy for that reaction. So I'm using the number that I got previously, which is 11.24, lots of numbers running around, kilojoules. And then I'm dividing it by the delta H. Now, in this case, my delta H is a different number because we're talking about a different reaction. So if we notice, it was this number here, the 19.9. Are you okay with how I got that number? All right. So kilojoules and kilojoules cancel out. I get per mole again, which is good because I want my answer in moles. So I'm taking that answer. Again, I don't clear my calculator, so I can just hit and reuse it. And then 19.9 is what I'm dividing it by. And I get N equals 0.565, and then lots of numbers underneath mole. And then I'm just using the exact same equation. I'm just working the same way, but backwards. You okay? Do you need me to explain anything again? I'm happy to go backtrack. Basically the same thing we were doing with lithium bromide, just working in reverse. All right, keep going. Okay. So I'm using this N equals little m over big M equation again. In this case, I'm trying to solve for little m. So I'm multiplying this by big M, multiply this by big M and big M cancel. So I have little m equals N times big M. And then we just plug that in. You guys okay? What are you laughing at? So that 0.565 ... moles times the molecular mass. Again, make sure you're grabbing the right number. So in this case, the number I'm grabbing is this number here, 119. Whoops, 119. Again, idiot check yourself using the units. Mole and mole cancel out. I'm left with grams, which is what it was asking me for the question. What is the mass of lithium bromide? Sorry, potassium bromide. So I take that number, multiply it by 119, and I get my mass that I will need is 64.2 grams. And let's do it in 3 significant figures just in case. That's my final answer. Same thing, just working backwards. And that's what you got to do. You guys okay? You're a lot of giggling, and I'm just really worried that none of this makes sense. All right, shall we look at the marking schedule just to see how this points broke down? Where's it gone? There it is. Alrighty. There you go. There you go. Oh, so they rounded down, which makes sense. That's fine. So their number is slightly different from mine, but that's because they did rounding and I didn't round. But that's not something they would mark you down on. It's the same answer, just different ways of getting there. So that's the same process. I got the same answer, I just rounded differently. So they rounded early. I didn't. Anyway, the correct number of moles for the lithium bromide or the correct mass of potassium bromide from incorrect moles. So basically, this first step here, this calculation wasn't achieved. So if you just did that first step, you got an achieve point. The other thing they were saying is achieved is you did all this working, but you made a mistake here, and then it's affected your answer down here. So it's really important that you show your work, because if you don't show your work, then we can't give you partial credit. And then last thing, or next last thing, this one, correct energy change or correct mass of potassium bromide, incorrect energy change. So basically it's just stating that you did this you did the mistake later in the problem. So if you did your mistake earlier on, that's an achieve point. This here is getting yourself up to a merit level. If you got a final answer here, but you made some error around here, then it's a merit. So that's why it's important to show your work. And then the last step is the excellence. So excellence was correct mass of potassium bromide calculated. So basically just having this final answer, you got an excellence point. So I personally don't find these questions too difficult because I like math and there's no writing explanation to this. So for most people, hopefully it is an easy excellence point. The challenge, like I said, with the rest of the, are you okay? So I personally round at the very end. They won't penalize you for something like this. Yeah. So they look like they rounded. I'm just trying to see where they rounded at in their calculations. So they were rounding all the way up here. So they rounded that number, which was this number here. They rounded. And then it looks like they were rounding in each step. Yeah, they were rounding in each step that they were working. So that is my kind of problem with this, is that they were rounding at each point, which is then going to make it less accurate. If you did that on the exam, they probably would still give you the point because it's just a rounding thing. And there was no requirement saying you need to round at every step. So I wouldn't be too stressed about that. Yeah, which is what I did here. So I'm guessing what they had done in each step was they were rounding it, yeah, to 3 sig fig each time. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So they're not going to split hairs over that. What they're looking for is, do you know how to do the process correctly? Yeah. Cool. So yeah, that one, like I said, correct mass. So it should hopefully be a fairly straightforward excellence point because there's no justification to it. That one's just talking about exothermic. And then this last one here, which I'll just show you guys the question so you're aware of it. It says, by considering the enthalpy change of each process, explain any difference in the resultant temperatures of each solution. No calculations are needed for your answer. So in this case, all they're asking about is, just here. So the dissolution of lithium bromide is exothermic, so the solution will be warm, whilst the dissolution of potassium bromide is endothermic, so the solution will be cool. So that's the difference between the two. They don't need you to explain anything about that. Just recognizing one's exothermic, one's endothermic. This was an achieve point to identify what solution is warm, what solution is cold, but actually looking in the vocabulary, that's what got you the merit. So that's what you're looking at there. It's a strange question, but yeah, just so you know what it looked like. Questions, concerns, comments? No? All right, that is it. So that is all that I would teach you in level 2 chemistry. We're done for the year. So just so you guys are aware of things to work on next. So, You have a couple options. There is the Mahi choice. So you have SciPad pages that you can do. Now you can do all the questions in there because we covered both versions of this calculation. Remember, just do what you need to do to feel confident. You're also welcome to just jump straight into the collated questions. I personally find when you get to the math section of these, the learning, you might as well just do the exam questions instead of doing the SciPad questions because I don't, like you might as well do the proper math instead of the weird scaffolded math. I don't find the scaffolding when it comes to the SciPad for the math actually all that helpful. You might as well do it against an NCA question. Once you feel confident, I put a CPR quiz on Google Classroom as well, but there was an error and it wouldn't make a copy for each person. So just kind of keep that in mind that you need to make a copy and then attach it if you want me to see and mark it. It's the same sort of setup. The only thing I want to point out to you guys is slightly different, just so you guys are aware, is in this case, instead of talking about mass, they've talked about concentration. So instead of using the N equals little m over big M, you're just using the N equals C over V. Yeah, and they give you all these equations on the exam. So don't stress about that. So just recognizing in this case, like for example, it's saying the volume of the solution of the hydrochloric acid with a concentration of 2 moles per liter. You're just basically acting with the concentration equation instead of the mass conversion equation. Here we go. And like I said, they give you all these equations on the exam. I can show you the resource sheet. Level 2 chemistry resource sheet. Resource sheet. Just so you guys know what equations you're going to get. It's basically all of them. There you go. And the mistake that I made the other day, you wouldn't make because you got the equation, and I didn't realize that you got that equation now. So, C, N equals C times V. Little m equals, N equals little m over big M. So they're going to give you those equations. So just read the question. If they give you something in volume, you're going to use this guy instead. And then this one was the bond energy one that I was talking about. So bond energy is bond broken. So bonds broken are your reactants. Bonds formed are your products. So reactants minus products. Cool. All right, that's all the equations you have for that one. These ones you don't have to worry about because that's the chemical reactivity one. We don't do that external, and then we don't do organic either. And then they give you a periodic table. All right, cool. The rest of the time is for you.